Okay, so let me share a link with you. So I'm pasting a link in the chat. Okay, so before I start, I just wanted to to mention that the plan for today was to completely, implement the full application using LangGraph, and sort of like as a continuation to what Kofi presented last time. But unfortunately, I was under the weather during the week, and I did not get a chance to fully implement what I wanted to do. But there's still a lot of material to discuss and to go over. And then we're gonna definitely have a second part to this presentation where we will go even in further depth on how to put together a web application that relies on LangGraph. So today, my hope is to at least make you aware of how the current landscape is changing around LLM and also web applications related to LLMs. And so I will give you a quick overview of some of the new tools that appeared recently. And then I'm going to show you at least some of the basics on how to approach building these types of applications. And also I'm going to draw some similarities with other existing stack. Any questions over? Okay, so this is my introduction. The way I try to like put a bullet point list of what these new tools that appeared made me think about. Um, has anyone heard about Fast HTML, which is a new library that came out within the last 2 weeks?
Not me.
Nope.
Okay. What about HTMX?
Yeah, we talked about it a few times.
Yes.
You actually have talked about it a few times.
Yes, we did go over it a few times. And then there's a whole range of JavaScript, not JavaScript, CSS libraries to help developers put together some nice UIs. So let's take a quick look at the first one. So HTML. Well, actually, I should have a link at the bottom. Let me see. That's HTML. Okay. So first HTML. Okay, let's take a look at this hello world here. So for those who have been coming to the meetings for quite a while, I have noticed that whenever we build a small web application in Python, to work with all of those LLM tools, we usually reach out for Fast API. Let me open it on the side. Fast API. We usually reach out to Fast API, and the purpose of this one is, as the name implies, to quickly spin up some APIs and then serve JSON data, right? But during the presentation, we have used it a little bit to also do HTML rendering, right? And it turns out that Fast API is actually a combination of 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 um, some it's a nice combination of other Python libraries such as Pydantic and another one called Starlet. So Pydantic is used for giving structure to data and also do data validation. And then Starlet itself is the HTTP server, right? So the combination that we used to do during the meetings was to combine Fast API with a template library, usually Jinja2 for Python. And then we also combine it with HTMX in order to have some client-side interactivity. HTMX, so this library here, right? So the interesting thing with this new library that just came out within the last 2 weeks is that it's also a combination of libraries, not unlike Fast API, but this time around the focus is on building HTML, right? So it doesn't, at least from the examples that I saw, it does not use the Pydantic library for anything like data validation. It places the focus on generating HTML, so that using this, we can still reuse Starlet, the underlying HTML, but we do not have to reach for Jinja2 for templating. And the nice thing is that they went further to provide a Python DSL in order to generate HTML. So you can see that by importing some Python modules, it's very quick to create a div, and then inside of it, a paragraph, that will contain some text. Okay. I'll show it to you more during the code review. So this one here will qualify as someone please write HTML for me, because HTML can be cumbersome to work with, but Python has a nice syntax, which is concise and clear. So it makes sense to use such a library, which is fast HTML, to streamline the prototyping of apps, especially in this part of the field, which is moving so fast, right? The second one, someone please write JavaScript for me. This one refers to HTMX, because with HTMX, it's possible to decorate the HTML elements with some extra attributes, and then those attributes can allow us to do to implement many different features that usually full stack developers or front-end developers will write by hand using JavaScript, right? So HTMX basically abstracts this away from the developer, so that they can just use the attributes to specify what type of interactivity they want done, and it just happens. Okay. And okay, and when it comes to styles, it's also possible to delegate the styling of web pages to some third-party tool. The most famous is probably the most famous these days is probably Tailwind CSS, right? Where you can literally inline the styles that you want without having to manually edit a style sheet. And then behind the scenes, they have a small compiler that will take care of generating the actual CSS for the app. So, any questions so far? Okay, so let me close a few tabs here, and then I'm gonna show you this. So, so this is the new version of the Ubuntu site that I've been working on. Yeah, this is the old one here, like which lives at this address, UbunTuHive.tech, and then I have a new version that I'm still working on here. And the reason why I'm showing you that is because with these new tools that came out, I started noticing some similarities with the stack that I use for re-implementing the site. So I'll quickly show you an example. Are you able to see my screen? Are you able to see my editor?
Mhm.
Do you prefer the light theme or a dark theme? Is it visible or readable?
Maybe increase the font, a couple of process. Yeah.
Okay, so let me go to, let me pick this for example. So here I'm using a language called Clojure, and one thing you will notice here is that like this is a function, like on this line 283, and then the body of the function is basically the same syntax for, I mean, used throughout Clojure, right? But it turns out that this syntax is so powerful that writing the language itself without having to do anything extra basically allow us to not only generate HTML like from this function. I mean, I'm also able to generate JavaScript. You know, I'm also able to work with my styles, and everything in the syntax is very consistent, right?
Question.
Yes, go ahead.
What do you actually mean by generate JavaScript? Like, what do you actually mean?
Okay, so this website here is actually running on Node.js, right? But I'm not writing JavaScript for that, right?
Okay.
So I write Clojure code that gets compiled into JavaScript. So basically, what I'm trying to say is that from a single syntax, which is the default syntax of the language, I'm able to target multiple platform, front end, back end with Node, CSS, you know, front end JavaScript.
So behind the scene, this code on the left side there, which is like Clojure, as you said, would behind the scene actually write the JavaScript that the browser is gonna run.
Yes, exactly.
Okay.
Right. And then for the new version of the site, like I'll show you a piece of functionality here. When I click this button, we open. I'll go quickly over it so to get back to the main subject. So if you observe the network tab, when I click the more button, um, like this one, it's not really a page refresh. That's the fact that additional articles are loaded onto the page was completely handled by HTMX, right? So in this same code that I was just discussing, you know, if you look closer, you can see some of the HTMX attributes, right? So I'll switch back here. Those are the similarities that jumped out to me when I started seeing the way that the Python libraries are moving, the directions in which it's moving, right? And I just found it interesting because um, from my experience of using Clojure and seeing what's happening currently the Python libraries, it seems to me that people realize that in this area of LLMs, there are too many intersections of disciplines, right? You have the software engineering, you have the data science, you have research, you have web development, design, and many other things. It's a lot to take in for a single person in order to be effective, right? And for that reason, they start to move into a similar direction as the Lisp family of languages, which is that instead of having to do something special for each domain, it makes more sense if the language is powerful enough to enhance the language through DSLs or macros, in order to work with a single code base from a single language as much as possible. Does it make sense? Okay, so let's proceed. And also, beyond the DSLs to simplify the implementation of apps, like within Python, like in the current case, it turns out that the HTTP protocols are even more relevant, right? Because there's this new approach to building UIs that are streaming. So by streaming, what I mean by that is that if you if you just notice your interactions with ChatGPT, you'll notice that it's very rare for ChatGPT or any of the LLMs to be able to directly serve the full response after a prompt or a query, right? Because there's a lot of processing happening behind the scenes, and it's really slow. So since it's slow, to mitigate the fact that it's slow, um, this approach to building UIs that are called streaming UIs um, has to do with sending the bits of data that the user requested, like as soon as they are ready, right? So, for example, if someone was asking for an LLM to generate, I don't know, 5,000 lines of prose, it's not gonna happen within a second, but every few seconds or so, a word or a sentence might be completed, and this can be served back to the user for consumption, right? So even though the whole process might take, I don't know, a minute or a few more seconds, a minute and a few more seconds, the user gets to see pieces of the content arriving almost right away, right? And in order to do that, some HTTP protocols, a good knowledge of HTTP protocols is crucial, especially with protocols such as server-sent events, as well as WebSockets. Any questions on that?
Yes, it's not really a question, but I was like, if you can restate what you said earlier, like about like the platform, like the streaming platform, how it's worked, because like I didn't really get that.
You mean the streaming? When I was discussing streaming?
Yes. Mm-hmm.
Yeah, so streaming, let me see if I have a server running here. 1 second. So let me start this one. That's part of the demo. Let me turn off this one. Okay. Okay, so this small application here, I think I've used it, I mean, a version of that in the past. What it does is that it's calling some random API. In this case, this one serves information about dogs, right? And and since I'm retrieving all of the information about that they have about dogs, I end up with a list, right? And since I end up with a list, just to illustrate the point, I'm adding an arbitrary delay and then serve the information of one dog at the time, right? So if I switch to my terminal, uh, okay. So when I curl this, actually let me slow it down a bit for you. But okay, I guess you can see what's happening. So if it's a bit fast, but I can slow it down. So what's happening is that um, the information about the dogs is basically being sent back to the client. Here I'm making a curl request. It's coming like one at a time, right? So if you imagine that this was an interaction with your LLM, and the required processing time is a bit long, right? The first few items may be ready almost instantly, like in a very short amount of time compared to the overall response, right? So so since pieces of the data are uh, become ready almost instantly, but not the whole response, we can send it to the client for consumption, which is what I'm showing here. Does it make sense?
Yes, it does. Yes.
Yeah, so that's what I mean by streaming UI. So in this case, you can see that I'm sending HTML divs, you know, like this one contains the wolfhound, whippet, you know, and so on and so on. It comes one piece at a time. I can actually show it to you in the UI as well. Open, see if it's open. Okay, so it's the same thing happening here. So you can see that the connection is open back to the server, and then the events are coming one piece at a time. And as they come, I'm just updating the DOM. Right, and it's also possible to send different event types. You know, like you can see in the names over here. Okay, so any more questions on that? Okay, so that's what I meant by streaming UIs. And actually, to be able to do this, it's not just the HTTP protocols, like some specific features need to be available into the language of choice. Because if you can imagine a scenario with like a lot of traffic to the back to the application that you are building, um, it's not really practical to spin up new threads in order to serve these types of requests. It's gonna be wasteful, a waste of resources, right? So it turns out that in Python, we have a couple of features that make it easy, trivial to implement, which are Python generators, as well as async IO. So if I show you this is the, let me stop this one. So this is where the HTTP call goes out to retrieve the dogs. And then there's this special keyword here called yield. And then this one will send one dog at a time back to the client, right? And then this is paired with the with async IO, like shown by this async keyword over here, so that it doesn't consume a whole thread. It's just a tiny process, and since it's tiny, it's possible to spin up a whole bunch of those processes, even for a large number of clients, and not waste any resources. Okay. So, okay. So let me see. Where was I? Okay. So this is pretty much it for the things that I've noticed. So let's take a quicker, a deeper look into the let's take a deeper look into fast HTML. So in order to send events back to the client using server sent events, there's a need to format the message in a very specific way, right? So like you saw in the terminal, the format of the message is pretty much as is. You need to have an event, and then the name of that event, and then the data. The data can be anything as long as it's a string, which is ended by two \ends, right? And then it can be encoded to UTF-8, right? So I have some links at the bottom of I have some reference links for back to some of the prior demos and explanations that we went over. So feel free to take a look at it for more details. But the the more noteworthy part here is that since fast HTML is now a thing, the syntax to actually format the server sent event message became much more simple. I think I might have a previous example. This is a different project. Let me see. I think it's render. Yeah, I think I kept the same function name. And you can see that in this previous version, this one relied on actual template files, like you can see on the right side here. Right, so it relied on template files. So I had to read those template files from disk, and then find the right one to use. Like in this case, the streaming chunk, like this one. And then I had to use that weird Jinja2 syntax. So like I was saying, it's a lot of noise for something that's actually quite simple, right? So if you compare this to using the new library called fast HTML, you can see that this is much cleaner. Basically, here we reach for a div. Okay, we set the attributes that we need. So in this case, we set the attribute of the one of the HTMX attributes. This one helps with the with updating the DOM, like I was just showing you in the browser, right? And since this is a div, it just takes this function to turn it into a string, right? So this function to XML, okay, and then it gives you this. So what took several files and multiple lines of code is basically down to, let me see, 1, 2, 3, 4, 5, like 5 lines of code with fast HTML. And I think I have an example here as well. Oh, it doesn't render here. Let me see. Yeah, I have the same thing here. This is an example output. So here I have an article tag that wraps a div and then some text, and then it also wraps another tag, a p tag, and then it renders like this as a string. Right, so it's very nice to use, and it's all within Python. Okay. Okay, so let's get back to where was I here? So let's get back to the LLMs with LangGraph. So let me see. Okay. Okay, so the first thing that I started doing when I started prepping this presentation is that from what Kofi showed us last time, I was trying to maybe to improve a little bit the ergonomics of how to set up LangGraph in order to start putting some functionality. Right. So the first thing that jumped out to me is that from previous demos, I like to switch around from one LLM provider to the other, right? And I like to do it without friction, right? So what I did is that I came up with this with this module, which is reusable in any number of LangChain and LangGraph projects, right? What it has is that it has an enum that basically like specifies the models that I want to use, and it's fully extensible. So if someone has a preference for another model, I don't know, like Mixtral or something like that, it can be specified here, right? And then the actual providers, could be OpenAI, Anthropic, or I use Grok a lot, Grok from Grok Cloud, right? And then once after this enum has been set up, then there's a helper function called getLLM that accepts uh, this enum, at least a concrete selection of within this enum, and then it returns the corresponding LLM, right? Because what it does is that it's using the values of this enum to set up a key value pair. So you can see that the key will be from this enum, and then depending on the provider, like in this case for Claude will be served by Anthropic, and behind the scenes, my my environment variables are already set. So I'll do it here. Yes. So I'm using a tool called Dear ENV. This one. you can install it on any system. It doesn't matter if it's Windows, Linux, Mac, and so on and so on. So what it does is that it detects that envrc inside your project folder, and then it inspects it, to find uh, all of the exported values, environment variables, right? And then once I do this command to allow it, then that's it. It's on my system. So since it's on my system, I don't need to do anything special in my Python code. I can just run my Python code as long as I'm in this path, and then the libraries will pick it up, because I make sure to use the standard names for the different API keys, right? So that in the end, my module is completely decluttered. Any question on that? Okay. Oh, I almost forgot to mention something. So let's see. I also run into this new project here that I found interesting. This one is from the people that develop, I think, character.ai, and basically they also go into that direction. They don't necessarily like provide a DSL, but they go for reducing the cognitive load of the developers who want to use this, right? So what they notice is that if I go back here to grab a link, yeah. So if we go to LangChain Hub, you can see that a lot of the reusable modules are usually prompt templates, right? So there's one here for React, right? And then there's a way to import it into the code. But the thing is, the actual text of the prompt is some of it might be hidden, so um, it makes it doesn't make it obvious what's happening at the prompt level, right? So I lost the link. Yeah, so what those guys are doing with Prompt Poet is that behind the scenes, they use the Jinja 2 library, and through that, they make it straightforward to structure the prompts in any way that you would like, right? And then, since it's Jinja 2, they leave some holes as well, for the variables. That way, if you wanted to do something like chain of thought and so on and so on, you just pass the variable values and without having to worry about the overall structure of the prompt, right? So this can be combined with pretty much any LLM libraries out there. It doesn't matter if it's LangChain or Instructor or some other ones. So, okay. So now that we saw So now that we saw how to declutter the setup for an LLM within the LangChain and LangGraph framework, um, there's another thing that I started looking for, which is called structured outputs. Because all this time working with LLMs, I've been using the instructor library a lot. let me get you the link. I've been using this library a lot, which is basically a way to um, send a prompt to your LLM of choice, and then get a data structure, a well-known data structure back, right? And it's able to do that with the use of the Pydantic library. Okay, right. So since I was used to that workflow of prompting and getting a structured data back, I started to look at how to do the same from within LangChain and LangGraph. And then I have a sample code here to show you. Okay, so this is a Pydantic definition, like with a couple of fields, like one for Markdown, one for code, that inherits from the base model. The LLM is selected by reusing this diskette LLM that I was just showing you, right? And then there is this helper function that I discovered that lets us put in the structure that we are looking for, the structure that we want back from interacting with the LLM. And I have an example of that. Let's see here. I think it's this one. Yeah, so just like I was showing you, we have the well-known structure that we define. We have the state graph for LangChain. In this case, I'm picking GPT-4 mini. Then I specify that I want this as the structured output. And then I define a couple of nodes since I'm using LangGraph over here. So the first node is to basically start the process of interacting with the LLM, prompting it. And then the second node is responsible for passing the response into this structure that I defined here. Okay. So if we run this, yeah, and then I define my graph over here. So again, I have the state graph in which I pass the message state. I have I add the chatbot node, and then the code parser, which is this one. And then I connect them, making sure to start with the chatbot. Then then finishing with the simple code parser. And then when I compile this and run, then I can request something. Give me an example of the Fibonacci function in Python. Okay. Okay, so you can see that it ran, and the output here comes from this. So I'm printing the explanations in Markdown first, and then on the next line, I'll print the actual code. So this is exactly what you're seeing here. And, and then since I have it running into a loop, and I have it, like have the human in the loop workflow here with the input, right? So it's back to waiting for another prompt on my behalf. Right? Any question on that? No questions, comments? Okay, so let's keep going. Okay, so always as part of improving the ergonomics, I started looking into the implementation of an agent class, because sorry about that. So I started looking into the implementation of an agent class, because when you look into LangGraph, you're gonna see a lot of code like this, right? So my goal here with this class was to understand some of the common patterns and try to abstract it away so that I can reuse it in different scenarios without having to repeat a lot of boilerplate. So let's take a look at this class. So the class itself is pretty straightforward. I'm using the out-of-the-box agent state, which is basically a list of messages, with the add function to append more messages. And then the class itself takes a name, for the name of to hold the name of the nodes that will contain the LLM of choice. Okay, and then the next input is the model, and the model, if you remember, I was just showing you the enum that lets us select the type of LLM that we want, and also implicitly picking the provider, right? And then the third parameter is the system prompt, right? So if we want to give this agent a role to play so that we can interact with it and then it can work on our behalf. And then the next thing is the available tools. If we want to make any tools available to this agent. And then the last input is basically this one is meant for a Pydantic class, right? So if we pass it a Pydantic class, then it's gonna understand that before it finishes running the graph, it should take the last output and structure it with Pydantic for us. Okay. So actually, I can show it to you in the small demo. Let me see. I think it's. I think it's this one. I think it's simple agent. Okay, here. So in this demo, I basically repeated the same class here, but I'll show it to you in action. So in this case, the system prompt is one. I'm basically giving this agent like the role of an agent that does some basic arithmetics. with the simple operations like addition, subtraction, multiplication, and division, right? And it's gonna help us do these operations for us. And then LangChain and LangGraph make these two annotation available to us, so that we can specify, we can define a tool pretty much, right? So the tool that we define obviously like takes two inputs for additions, same for subtraction, multiplication, and division, right? And then I just pass these values to the default operators in Python to do the same, right? But one thing that's important here is that the docstring is actually required by default. Otherwise, the graph is not going to compile, right? Then once I have all of these tools defined, I set them as a list, and then I make them available to the agent. Okay. So, yeah. And then again, I pick GPT-4, and then I use the system prompt, which is what I just showed you here, and this list of tools. And then again, I'm using the same thing with the human in the loop so that it prompts me for input. And then I can copy. I've pre-written this one over here. I'll run it from the terminal so that it's nicer to see. So this one is simple agents. Okay. So I'll copy this one here. Okay. So what does it say? So my user prompt says, well, Mrs. Adjo receives a stock of 50,000 pineapples a month and is able to sell 4/5 of it. What is her monthly gross revenue given that pineapples go for $5 a piece? What are her monthly losses? Making sure to calculate her losses based on the unsold pineapples. What is the ratio of her revenue to her losses? Is she profitable knowing that she buys a stock of pineapples at $2 a piece and has a total of $80,000 of operating expenses? Respond with plain language. Right? So again, if I'm pretty sure you're familiar with like how good at math the LLMs are, right? They are not, right? So in this case, it's gonna reuse the Python standard library to actually do the calculations. If I run this. Okay, so I try to like use different colors to be able to tell one output from the other. Okay, so what do we have? Well, I guess you can read this, but you can see the operations took place, and Mrs. Adjo is actually profitable, making a profit of $20,000. Yeah. Any questions on that? No questions? Okay. So with this. Okay. So what we just saw is that uh, it's actually possible to hide away some of the boilerplate code of assembling and an agent with LangGraph into a class, right? And then we can add, we can extend this class or tweak it to our needs. So let me see. Okay, so let's take another a look at another example here. Okay, so in this example, see, in this example, I'm using the same class, but this time to be able to predict the weather, right? So I give it a name as the weather predictor. This will be my system prompt, and then my selection of model, then my list of tools. So in this case, my tools are defined into this module over here, right? So I have a tool which is responsible for constructing the URL to the weather description image, right? And then I have another tool for actually retrieving the weather information. Okay. So, and then let me see. Am I looking at the right one? Yep. So let me run this one. What the agents.py. Okay. What's the weather like in New York? Okay, so you can see that it was able to make use of the, oops, a terminal crash. Sorry about that. I have to restart it. Okay, so I'll just rerun this. Okay, so you can see it was able to trigger the tools and pick up the weather data, and also construct the let's see. Yeah, also construct the URLs for the icon description of the weather. Right. Okay. So now that we have this class, you can see how we can reuse it for many different types of agents, right? And then there's something that I started researching. That's the part where I haven't fully completed it, but I'm just gonna give you a glimpse, right? Because my idea here with this agent I just showed you was that this was just a simple agent to retrieve the weather information and massage the data like a certain way, right? But then what if we had like a weather team, right? A weather team in which one team member will be responsible for working on the predictions. Another team member will be responsible for drafting a description that makes sense for the people who want to receive this information, And then there could also be a supervisor to manage them and assign them tasks. So this is not 100% complete. It mostly works, and I still have some fixes to do. So, okay. So you can see that I'm defining a few pydantic models. And the reason for it is that each one of the agents that are specified, whether it's the one that writes the descriptions or fetches the weather and manage and massages the data, like I want the final step to return some structured data. And that structured data can be recombined at another stage to do something else that's useful, right? So that's what you see here. So again, I have a tool, but notice that this time in my tool implementation, I actually have an agent, right? And the last stage of that agent is actually a list of predictions. And these predictions are defined here, right? So the final output of that first agent is well known, right? And it works as part of a tool. And since it's a tool, like I have this similar setup for the agent that's gonna be responsible for describing the weather data, right? And since they are set up as part of tools, it means that they can be reused as part of another agent, right? So you can see that the same structure I showed you for the agent, in a way can stack up, like Lego bricks to make something more powerful. So let me try running this. Oh wait, I'll run it from the terminal. So weather bit team. So let me copy the initial prompts. Okay. Actually, let me copy this one. Okay, so you can see that now it's gonna do way more work. So basically, I mean, if you do clone the if you clone the project and run it on your system, it's gonna be easier to read the outputs, but you will see that there's way more work involved because every time something is dispatched to one of the tools, which itself leverages an agent, that agent also has tools within it. You can see the call graph um, can become quite large in order to derive the answer that we're looking for. Yeah. Any questions on that? Or any comments? Okay, so let's go back here. Okay, so what did we do so far? So we saw the importance of leveraging DSLs in order to reduce the reduce the cognitive load, right? And through the use of DSLs and HTTP protocols, we can we can tackle some more ambitious tasks, right? And since we saw what server-sent events are, right? We saw how to quickly put together some agents. It would be nice to see how we can integrate this back into a fully back into a working web application. So I'll show you the next demo. Let's see, I think it's this one. Okay. So I'll quickly walk you through it. So this is another fast HTML application. Okay. And in here, what I'm doing here is that I'm defining another LangGraph agent. I'm doing the simple case now. And earlier in a similar loop, we had an API call to retrieve dog details and then serve them a piece at a time using a generator. In this case, instead of the API call, we are running the LangGraph agent, right? And then as soon as the answers from the agent become available, we just yield them. And then you can recognize the same function that we discussed earlier. So you can recognize the same function we discussed earlier to allow us to format the server sent event message, so it can be successfully sent back to the client. Okay. And then this is where those events would be streamed back to the client. And see. And then since this is a chat app, we need a handler for the post requests that are coming in. Right. So this is how we define the post with fast HTML. The function name pretty much has to be that, right? So post and then the path. And then inside of it, we return some HTML. But the HTML we return here is a bit special in the sense that when this one returns and it's rendered on the page, it's gonna take care of setting up of establishing the server sent event HTTP connection with the server. So this slash chat stream is basically this function over here. So this one is a get, and this is a post. And then the home page is this one. Right. So the home page only has a single input field, which is set up inside the form. Okay. And then there is a div at the top to basically hold the responses streaming back from the server. Right. And notice there's no Jinja template or anything like that. It's just pure Python. So start with this. Okay, let's go back to the browser. Okay, and this is what it gives us. You notice how it's already styled, right? It's because by default, the fast HTML we use Pico CSS behind the scenes, it's possible to override it. By default, it will also load the HTMX library, right? But it's also possible to add extra JavaScript libraries or modules. Like in the case of this one, the SSC, I'm the one adding it at the top over here. So this one provides the extension to HTMX that allows to easily establish server-sent events, HTTP connections with the server. Okay, so I'll just enter some bogus query. Yep, you can see the answer coming back. Any question on that? Okay. So a couple of remarks on this small demo here. If you consult the fast HTML documentation, you'll notice that the chat example that they provide actually relies on WebSockets. So I'm not against WebSockets, but I have a preference for server-sent events. And the reason for that is that in a real-world scenario, like in terms of deployment, it will be much cheaper to run something on SSE for server-sent events than WebSockets, because the WebSocket connection is persistent, right? Whereas in my case, what I just showed you, as soon as there is no more data to send back to the client, I make sure to clean up, and free up some resources on the server. Okay. Well, that's all I wanted to bring to your attention. So let me see. Let me go back to my notes. Let me see if I missed something. Oh, yes. There's one last thing that I wanted to discuss. So let me share this link. So I'll put the link in the chat. Yeah. So going through the implementation of LangGraph on GitHub, I started noticing this word or name a lot, like pregame, and I got curious. So when I looked into it, I ran into this paper. It's by some people from Google, and essentially this paper discusses graph computations, right? The way that messages are being passed from one node to the other, whether the computations will run like asynchronously or eagerly, or how many nodes will be processing at any given time, and so on and so on. And again, that raised another no, let me rephrase it. That jumped out to me as well, because from the starting conversation of today, I was showing you how some of those ideas being implemented now in the Python ecosystem are actually available in other areas, right? Like we saw Google, and I showed you Clojure. And when it comes to computation graph, I actually have an example here to show you. So for example, here, I'll show you the corresponding page. 1 second. Okay, so when on this page, right? It's something you've seen plenty of times in most web applications out there. There's nothing special about the rendering, right? It's retrieving events and then displaying them into the list, right? But if you imagine the typical code, there will be like an HTTP request, and then the data comes. It has to be like passed as a JSON, and then if you're using TypeScript or Pydantic or something like that, uh, you have to use it to validate the data that you got back and give it some structure so that you can access the different fields and so on and so on. Like all of those manipulations, you have to check for nulls, do all of those things, right? So essentially, the same thing is being done here, also using a computational graph, but within the language itself, like using this tiny library. So, so if you just look at this part that I'm highlighting, I don't know if you see my cursor. If you look at this part, it's basically a hash map, right? With the keys on the left. And then we have those weird things over here that look like functions, right? So those are basically the computations. So on the left, I have the keys that will represent the results of the computations that are specified on the right side. So I have the raw results as the first key. These raw results will be passed in the next computation to retrieve the items of the event list, right? And then that event list will further be passed, into this structure over here. That can be in the end used to render this list over here, right? You'll notice there's no if statement, there's nothing like that. We just in a way the graph is almost like declared, and then the computations happen, right? So I found it interesting that this idea of computation graph by Google uh, made it to LangGraph. And well, the example I just showed you, that's from another guy from a few years ago who developed this computation graph library for Clojure, to simplify the data manipulation within the language. Yeah, so I think that's pretty much what I have for you today. Like I said, I just wanted to today give you a quick overview of how the Python ecosystem is changing, and also give you at least some basic tools or basic building blocks, on how to start approaching like putting together apps, LLM apps, for the web, with LangChain. And then in another session, we're gonna see something more fully implemented, and then yeah, we'll go from there. That's it. So the floor is now open if you have any questions or comments.
I don't see anything in the chat.
No, I don't have no questions.
No comment either. The only thing is, I think I'm going to read a little bit more about the fast HTML. That's it. New concept for me. But everything was crystal clear. I mean, I would have to go back and digest everything, but it was good.
Yeah, thanks. Anyone else?
Thanks for powering through your sickness to get our presentation going.
Yeah. No worries. Yeah.
Hi, Ben.
Hi, Kofi. Yeah.
So, are you saying we can use the fast HTML without using those Ginger templates?
Exactly. Yes. Just Python. Just write Python.
Oh, nice. Okay, I'll check it out. Let's see.
Yeah. And the nice thing with that fast HTML in their approach, because they are not the first ones to try to tackle HTML with Python, with straight Python, but a lot of the other libraries that I saw, I think I even presented one like a few months ago, like at least the previous attempts that I saw were basically building single page applications with a Python syntax. So what that means is that if you were to build a full web application with it, it wouldn't be visible to web crawlers, so your SEO will be down the drain. Whereas with fast HTML, it's actually a server rendered, web application, so the SEO is gonna be great, and plus you have the interactions. Oh, John, do you have a question?
Yes, thank you.
Yeah.
Let's say that I'm using a database to persist my connection information and the information that's captured along the lines for an audit trail. So I want to persist an audit trail of all the transactions going on. How easy would it be to perhaps implement connection pooling for my WebSockets so that I could control the amount of memory being allocated?
Control the I mean, as far as I know, I don't think there's connection pooling per se for WebSockets. I mean, okay, so let me explain. Like, if you take for example, if you take a scripting language like Python, right? There's no way to. I mean, you can put a number, an arbitrary number there, so that when you see a certain number of connected users, you can stop accepting connections. But that will make up for a not so great user experience, right? There are other stacks like on the Erlang VM, where it's possible to allow a very large number of connections, but that's a completely like foreign stack. So my suggestion would be to look into AWS. AWS has a service. I forgot what it's called. I think it's part of the API gateway, but it's instead of being HTTP requests, it's WebSocket. So if you look into that service, you can integrate that with your web application, and you will let Amazon handle the bulk of the traffic, the WebSocket traffic, and behind the scenes, for each connection, every time a user sends a message, behind the scenes, they send you a simple HTTP request back to your app. and your app can reply as it usually does when it serves HTTP requests. And then they will grab that response, turn it back into a WebSocket message for you, and send it back to the client. That way, it's something you don't have to think about. So,
Good advice. Thank you.
yeah. Let me see if I find that link. I was trying to use it like a while ago. Gateway WebSockets. Yeah, I think it's this one. Yeah, I think that's the one. So I'll place the link in the chat. Yeah, that way you can scale it to an arbitrarily large number, and you will still get to use your stack of choice. You know, you don't have to use anything special. So,
Brilliant. Thank you, Benjamin.
yeah. Anyone else? Sundar, no questions today.
I'm just observing everything. It's just, I learned so much. Sometimes I feel like, every time I'm trying to integrate what I learn, you guys are always, touching really, really good, topics. So I'll definitely, I'm a UI guy, so definitely I'll try to use what you showed today.
Mm-hmm. Yeah.
Yeah, I really appreciate that.
Yep. And we still have half an hour, so in case you guys can, if you want to bring up, if you have any topic or any suggestions or any volunteers even for presentations or anything on your wish list for presentation.
The one thing that I kind of like stumbled upon this week was Flux AI, their new image generation tool, which generates it generated like an Olympian who won a medal, and it looks so realistic that it's kind of scary now. Like how these image generation tools are becoming very, 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 very efficient in terms of creating lifelike pictures. Yeah.
Mm-hmm.
So very interesting.
Nice. So what is it for?
Flux AI, FL. Let me show you. It creates images.
Okay.
Let me put it in the chat here. They do other things, but yeah. Flux AI, yep, AI. You can search for image perhaps, and you could pull up the one that it created recently.
Mm-hmm. Oh, it's the same link. Okay. Isn't this? It looks
So,
like a cat. Commercials.
yeah, it's not. I have the image here. I can share it. It's pretty.
Yeah, eventually I want to start doing stuff with with images, because I mean, so far I've been mostly focusing on text with LLMs. That would be interesting to play with.
If you don't mind, if I can share real quick, I'll show you the image that I'm talking about.
Yeah, go ahead.
So the one on the right with the three.
Oh,
Yeah, I saw it. Apparently, they're fake. They're created.
oh, I didn't. Wow. Okay.
Isn't it crazy? It looks so
Wait,
real.
AI right there?
Yeah, this is AI. On the
Wow.
right here, the tree.
Wow. Okay.
Yeah.
I mean, I had no idea. I thought they were just.
Yeah, it's fake.
Wow.
But the thing is, like, I always ask myself, like, well, the AI is gonna create images, and it's based on images that it knows, right? So isn't it? And they say that these people don't exist, but do we really know that there isn't anyone out there who actually looks like this? You see what I mean?
The only way to know is to check everyone.
Is everyone online? That's the other question. Is anybody
Yeah.
online these days, right? Yeah. So, anywho, that was kind of like a quick comment on this.
Wow,
Uh,
that's impressive.
yeah. It's crazy, like images and audio and videos and the whole thing with deep fake. It's gonna be pretty scary to know what's real and what's not real.
I would like to say something. You
Hmm?
know, I'm thinking about maybe like a database because now we have all this face recognition. I'm pretty sure that, you know, in the US, the UK and stuff like that, they might have a database. But if they can render that public so that we can, I don't know, check, compare if those people are real or not. I know the database is not going to be, how can I say that, exhaust? How do you say that? You know, complete because new people, you know, we have to constantly update the database. But I would say a first, like a starting point will be if we have access to those facial recognition database, we should be able to compare and see if they exist or not. That's my take on that.
Mm. Yeah.
You know, like I think when it comes to AI and ethics, most of the large providers, they like I think they either they are still implementing it or at least they have a partial implementation for which, like, whether it's the generated text or image, they add some tiny faults inside of it, right? So to the human viewer, like the human will look at the picture and couldn't tell the difference, but programmatically they can detect those tiny faults, and that's how they know that an image has been LLM generated and another image is actually a real image. So
So, I mean, so since you said that, do you think I don't know of any tools right now that can, again, going back to what I was talking about deepfake, right? And how sometimes you see things on Facebook that people comment like it's real, but it's actually AI generated. But do you think that in the future we might have tools that could detect posts that were generated by AI and things like that, and then kind of like flag it, similar to how you get flagged on Twitter when you
yes, they do that right now. They
Okay.
already it's not on a large scale yet, I don't think, but they
Okay.
already
I would say they do that because, you know, there was a scandal with the Princess Kate, you know, recently because, you know, she was hiding from public and then she photoshopped, you know, some image. And I forgot the agency, I mean, the company, they are very huge in the picture, you know, sometimes they sell pictures, you know, so they were able to see that they were touched, you know, they were not authentic pictures. That's how, you know, the scandal came out because they were able to, with their tools, to see that she photoshopped, it wasn't something real. So I will say that they have tool out there already.
I hope it can be done with audio too, because audio is another one that's crazy as well. So
Yeah, they do that, like anything digitally I mean generated,
Mhm.
they have a way to market.
Yeah.
So,
Let's go.
yeah. So one last thing. Let me share my screen real quick. That's one last announcement. I don't know if you saw this announcement from OpenAI. Yeah, because for quite a few months I've been bugging you with structured outputs, like when interacting with LLMs. Well, it turns out that OpenAI started to implement that feature directly within their offering, right? And when I was looking at it, the funny thing is, for the Python implementation, they started using Pydantic. So I just thought it was funny.
Yeah, which
So,
I've been using these talks for 6 months now.
yeah. Yeah, and basically, if the fact that they are adopting it, it's only gonna be a matter of time before the others also start doing the same. You know. Yeah. Okay. And anyone else? Oh, actually, last time you mentioned that you wanted to prep something for DevOps, right?
It's muted.
Sorry about that. I was trying to unmute myself. Yes. Yes, I want to implement something from DevOps. Yes.
Do you know?
But in
Yeah, go ahead.
not the next session, the session after that.
Session after that.
I want to present, yes. Yeah, I want to present something from it's basically brilliant project. What I need to I want to showcase like what we did, everything.
Okay. That's it.
Mm. So not the next session, but the section the session after that. I think I will be ready.
Yep.
Mm.
So are you gonna put some LLM into it?
No way. No way. I will do it like DevOps and how I can manage everything like with one click. I'm not gonna do like the LLM. Maybe I will implement one chatbot, but let's say a chatbot to know what kind of music you like, something like that. Something really simple, not a big deal.
Okay.
May I know who all are using LLMs at your job place? If anyone using,
Who's using LLMs? Yeah, I mean, I didn't let me see. As for that one project in particular, I mean, we're not doing something too fancy. It was more like, I mean, some of the team members were doing some fine tuning for generating unit tests and stuff like that. And then some of us were building UIs for it, and then I mean, yeah. So we did it for a few months for like a proof of concept. And recently we had like an internal like challenge where people were training like some LLMs for like a competition and stuff. So,
Okay.
okay.
Anyone else?
And I also recently did a small certificate, like because now more and more you have all of those AI engineering certificates becoming available, whether it's on AWS, Microsoft, and so on and so on. So I just did a small one recently. Like, it's just beginner level for now, but I plan on doing something more advanced later.
Oh, okay. I'm starting deep learning in 2 weeks.
Nice. Nice, nice, nice. Are you gonna do PyTorch or TensorFlow or Keras or?
I think it's PyTorch. It's part of my master's program.
Okay, okay, okay. That's nice. That's nice. That's very nice. Right, so it means you're gonna start teaching us deep learning, right?
Yeah, I'll put something together in December, right after.
In December.
Yeah, because I have to learn it first, right? I know some of it, right? But I want to learn from the course and then, do a webinar based on the course.
Yeah.
Yeah. So I think by December I should be done with the course, and then I can come up with a webinar.
Yeah. Yeah, that's neat.
Yeah.
Is anyone else doing any courses or certifications? Or
Yes, me, I'm trying to do like Azure DevOps.
Azure DevOps? Okay. Okay.
Anything else for today? Ben, anything else?
No, I mean, not really. That's
All right.
yeah. I just wanted to give a quick overview of some of the new stuff happening. But yeah.
Well, thanks again. Thank you for doing that.
Do we have the next presenter? Or
Oh yes. The next presenter is supposed to be Derek. He presented once. He presented once about the. I think he was presenting on HTMX, some LLM, and then the data visualizations. for the energy industry.
Oh,
So,
right. Okay.
yeah, so we were discussing, and he had like an idea to make a presentation about graphs, but not the same type of graphs we've been seeing today, but like actual social networks, like type of graphs.
Mm.
So to like basically,
On this one,
yeah, go on.
don't forget to put like, don't forget to add people to trying to be collaborative on this project.
Yeah, I'm gonna. Yesterday he called me, but I was a bit busy. I have to call him back again today to see. I mean, to make sure he confirms it.
He's here.
Is here? Derek is here?
Yes. Yeah.
Oh, I didn't notice. Hey, Derek. Let's see.
Probably on mute, but yeah, Derek is here. But we can confirm. Yeah.
Okay, yeah, but I mean, it's very interesting, at least from what I got, from what I gathered during the conversation. So it's um, yeah, basically it's about modeling like relationships between people and do some interesting queries and visualizations and stuff like that. And maybe some LLM in between. I don't know.
So LLMs really going to take software developer jobs?
No, I don't think so. I think it's more like so okay. I don't even know how to explain. You know, usually we just do the basic stuff, right? You send a prompt, you get a response, send a prompt, and maybe get structured data, and that's that, right? But once like more and more people figure out the what they call the agentic workflows, then I think software development is gonna move to another level. Not that it's going to replace like software engineers, but software engineers will start doing more interesting work. That's how I see it. You know? Yeah, because for example, last night I was watching a demo of a guy building a tool, and the tool helped the guy build itself. It's like it was weird. He had like a strange agentic workflow in the background, and he was developing that. So. But no replacement, I don't think.
Yeah, I think so as well. The more you look at things, the more you know that the dependence will be on developers. Definitely the skill level will change, but you still need software developers.
Yeah. 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 Yeah.
At least in our lifetime, right?
Yeah, it's like happening tomorrow. Almost. Oh, I say you said Derek is here. It's I think it's another Derek. It's not Derek Taylor.
Oh, Oh, then Pratt. Okay, my bad. All right, well, we'll send out the schedule for the next one. Shortly, I mean, very soon once we get the information from Derek.
Yep.
Thank you, Benjamin.
Yeah, thank you guys.
Yeah.
Wait.
All right. Thanks, everyone.
Thank you.
Thank you.